Hi, I want to show you on this video how we can find out the gravitational potential energy on the Earth or on the Moon. Okay, so before I do that, I want to remind you guys that what we saw with elastic energy. All right, we figured out that the units on elastic energy are newtons times meters, but we also saw that a newton is actually a kilogram meter per second every second. Okay, so all these units are a newton and all these units are a meter. So these units all together, okay, are actually what we call a joule. And that's why we call it a joule because we're sick of saying all these units all the time. All right. So now let's look at Earth and Moon and see if we can figure out how to calculate the gravitational potential energy in those. Okay. So I'm going to write the gravitational potential energy. I'm going to call that EG, gravitational potential energy. And then you people have been telling me that the things that determine how much energy that rock has is how high it's up on the um, how high it's up on the hill. And also, you've been telling me, I think, that if it's on the Earth, it should have more potential energy than on the Moon, because Moon is not pulling it as hard. And also, you've been telling me that the mass of the rock matters. Okay, so I'm going to write all those into an equation and see if that could be energy. I'm going to write that we have 1 kilogram rock on top of the hill. I'm going to write what you already know, that the acceleration due to gravity, or the pull of gravity, we can call it that, is 10 meters per second every second. And I'm going to call this height of the hill 10 meters. Okay, so it's a 10-meter tall hill. So I'm going to write 10 meters right there. All right, now let's think about that equation for a second, what I wrote, okay? Is that really the energy? Could that really be the energy? Well, let's see. Let's go up to the energy that we saw in a spring and see if that's the same units. If it's the same units, it's probably the same thing, all right? Well, these units here are going to be kilogram, meters per second times meters. Here's the energy. Here's the energy units for the spring. Kilogram, meters per second times meters. That equals a Newton meter or a joule. But these are the same, right? Kilogram meters per second times meters is exactly the same as what we had up here for the spring. So this must, in fact, be the equation for the energy on the moon. I'm sorry, on the Earth. Okay, so I'm going to write that as a formula that you guys are going to need to keep. Gravitational energy is equal to the mass multiplied by g. That is the acceleration due to gravity. Okay, that's this number on Earth, and multiplied by the height. Okay, now height is still a length. That's why it's in meters. It's why it's kind of like what's uh, in the equation for the spring. All right, mass times gravity times height will give us the energy that is stored in that rock on top of that hill. Okay, so we can write the same thing for the rock on the moon, the same equation. It'll be mass times gravity times height. And so I'm going to write that the gravitational energy on the moon would be the mass of the rock times gravity on the moon, which is only about 1.6 meters per second every second. There's less gravity on the moon, times the height, and that hill is the same height as the one on Earth, so it's 10 meters. So the rock on the moon, if we multiply that out, it's only going to have an energy of 16 kilogram meters per second times meters, okay? Which is 16 joules or 16 Newton meters. Those are all the same thing, all right? So keep that formula in mind.